Hi everyone, here we're back at Maker's Machining again. Saturday this is Monday, Saturday we did a little video on turning left-handed threads, and then I came over by this machine where we were making this flanger. We got some pipe threads inside there, and I explained how we did some live tool tapping in this part here. So I'm going to introduce you to Joe here. He's our lathe dog guy over here, and those of you who don't know what a lathe dog is, you'll have to look that up. But it is a real part that is used in machining. Anyhow, Joe has gotten this thing all programmed up here, set the machine up. We're going to run a part without coolant on it so you can see inside the machine what's going on. And then Joe will give you a little rundown on how he used his live tooling in the machine to do the two tap holes, which you'll see the operation, and then tell you about how he made the fixture for it. So we'll get this lined up here, Joe, and we'll get Tom to run a part here, and we'll kind of watch the video through the door opening here and get our part lined up here. So Tom, if you want to go ahead and do your thing here, we'll set that piece in there. Let me get in here to watch how you fixture this thing here. We've got a fixture that holds the shape of the burnout and a couple of clamps that we put on there. And that locks it in tight and holds our part tight in the fixture. You can see the shape of the fixture has an opening the same size as the part, and we'll tell you what that's for in a minute here. So we got the clamps far enough away so we can do all of our machining operations. So let's go ahead and I'm going to close the door here a little bit. I'm going to hold my arm in here and let's let her rip. I'll try not to get in the way. We got a flashlight we can throw in here too? All right, by any chance? Okay, let's go ahead and do it here. What kind of RPM we going here, Joe? 280 RPM. This is a 4-inch pipe thread, and you might have heard some interrupted cut when we made our first pass. We had to make the hole on the burnout smaller. Okay, smaller. The RPM just went up to 450. The first cut is nasty because we've got a little tang from the burnout in there. And now we're getting our bore cuts finished up. Our thread size and a chamfer on there so we can get in there. Are you doing a chamfer on the back of the hole while you're in there too? Next operation, we'll reach into the boring bar and do the back side of the hole so you've got a chamfer on both sides. This is your tool changing here. It reaches in there and cuts out the shavings that are hanging in there. Okay, I hope you can hear me with all the noise from the machine. Okay, now we're going to turn around here. Look at how quick that index is. And we're going to thread that hole in there. Now I said Saturday when we did this that this thing, after it does its blade work, which is what it's doing now, this changes modes into a milling operation. So we'll open the door a little farther here because the chuck's not going to be spinning and throwing out chips. We got a bunch of passes in here that give us some thread. How many passes you got in the threading, Joe? We're getting a red chip out of there, too. Probably is a good idea to keep coolant on there, but for illustration purposes here, we're doing one without the coolant, so we might end up changing our threading insert after this piece and have to go run it through again. Okay, as you can see here now, we've got our spotting drill going in there to put a mark where the tap hole is. So the chuck is not turning. We're getting our spotting drill marked deep enough to give it a chamfered hole. The chuck just indexed 180 degrees. We're going in with another spotting drill here. And then I'm going to guess that after this spots, the turret's going to go back, index around, and bring in a drill. Okay, well, went back to the first hole. It indexed around, now we're drilling the hole. It's got a peck cycle in there to get the chips out of there. If you notice here on all these holes that we're doing, the one we bored out, the fixture has got a big hole bored through it, so there's no blind hole that we're tapping. And the same with these tapped holes here. We're putting I think it's a 3/8/16 thread in here. So what diameter drill you got there?
That's 5/16.
5/16. That's your tap drill size. All right, you saw how quick that went around here. Now we're tapping that hole in and out. This is all done with live tooling in the turret. There's a planetary gear behind the turret that the individual tools reach back out. That thing's done already?
Yep.
Man, that didn't take long.
Careful, Tom.
Look at that.
Kind of hot.
Yeah. Okay, Tom. Stick your hand there, try not to burn it, and we'll take that piece out of there. Gotta watch out when I step back here so I don't step on the chuck release mechanism. So as soon as we get that out of there, we're gonna have Joe come in and explain a little bit about our fixture that we've got here. Okay, Joe, come on in.
So we use the live tooling to mill a pocket in our fixture, and we also milled a flat on the top of the fixture so we could put this fixture in another machine, orientate this flat and be able to, or indicate this flat and be able to orientate the piece.
Yeah, the two tapped holes on the side are parallel with that flat, so
yep.
you have to know where you're at, so you can set your machine, say, okay, this is our axis for where we're going to locate our tapped holes.
Yep.
You can see the clearance that's in there for the 3/8 taps.
We have 1/2-inch holes, so nothing binds up when the drill or tap go in. The parts are pretty good all the way around except for a little hump right here, and they're in the same spot on every piece. So we milled, I don't know if you can see that, we milled a little notch in the fixture so that part goes in the same way every time. And
you do also have that hump on the bore, which on our first boring pass you could hear it taking kind of an interrupted
that's why the RPM was slower on the first pass.
Yeah.
The kind of that scale, scale's pretty hard, so that first pass the RPM's about half of what it should be, so we don't tear up the tool.
Yeah, we started out with like 220 RPM and then it went up to 450 once
pretty much,
we had a good round machine surface.
And that's pretty much all just to save the tool, because we're using one boring bar to rough and finish, and we have quite a few pieces, so we're trying to maintain tool life a little bit. So.
Okay. Your machine here can do 48 inches between centers, I believe.
That's the work space. Depending on the part, we could go maybe a little longer or not quite as long, depending on the part and what we need to do to the part.
What are some of the other milling operations you do while the part is in the lathe? Because typically, if we are doing lathe work here, but we're also doing mill work. Otherwise, without a live tool lathe, you'd have to go and put this in a fixture in a milling machine and tap the holes independent of what we're doing here.
Yeah, and you're handling the part twice as much as you need to.
Yeah.
And here the part comes off complete. It doesn't have to go anywhere else, and you're saving time, saving money. So, but yeah, we could drill and tap, mill, shapes. I mean, pretty much anything on the face of the
Look
part.
at that pocket in there.
Yeah,
that's not a round pocket in there. That's
the shape of the part.
That's the shape of the flange. So we put that in the lathe and milled that pocket while it was in the lathe.
We did everything on this fixture in the lathe.
Yeah, pretty cool.
Drilled and tapped the holes. We were trying different clamps at first. They didn't work out too well, so we have different tapped holes. We have the notch up here. We have the shape. All the holes. Everything is done.
So if you're making shafts, you can cut keyways in the shafts without taking the part out, and those actually have different kinds of tool attachments here, where the cutter sticks out towards you instead of towards the
90 degrees to do keyways or cross holes and shafts, stuff like that.
So anyhow, this is it's basic machining, but it's a little bit more automated, and we've got our control on our machine here, and it's got all the G-code lines that you can single step through the program as you're setting it up. You've got the tracing that shows the shape of the part. Here we've got a stack of finished ones here, and Tom's chamfering the back of the tapped hole, so it's all burr free and everything. So
checking with our go no-go gauges.
Yep. So get a precise part that way. I don't know what's the tolerance range. Is it like about a 5,000
It's a 10
range?
thousandths range for the pitch diameter.
Pipe threads are usually pretty forgiving.
Yeah, they're pretty
so.
loose. Yeah, that's a pretty
Anyhow.
cool part, and it's nice to be able to come off complete.
Yep.
And, you don't have to double handle it.
Doesn't take long, but first you got to make a fixture, and you got to get the program made up. And we had a little different clamping arrangement to start with that we had to change. So,
Yeah, anytime you got a new job, you have to work all the bugs out to get it to run smooth. So
yeah.
I think we're on our way.
Take a look in there once. I just wanted to get you on the back of your hat there. It's got a White Sox hat on there. Go Sox!
That's right.
Okay, well that'll be it for today. So I hope you enjoyed the tour there, and we got all these Sox